Okay, good morning, you guys. Today is Wednesday, October 14th. Hopefully, yesterday went well for you guys as we kind of jump back into, um, chapter one and continuing on with this stuff. What you are going to continue to notice is that so very much stuff from the first quiz that we took is going to transfer over. Okay, so that first quiz, the first half of this chapter, are really just kind of like the prerequisite skills that you need to be able to complete the second half of this chapter, which was very evident yesterday based on the fact that you were solving systems by graphing linear equations. So obviously, graphing lines and writing equations of lines was a very big part of that quiz, and it really led into what you did yesterday. It's going to be the same thing here. Sections 1 and 2 from this chapter, your ability to just solve equations, solve multi-step equations, is going to be on full display today. Okay, we're going to be doing, it's going to be a blending of of ideas here. You're going to be doing and performing all those basic skills for solving equations, but you're going to be using it in a way that allows you to solve a system of equations. Okay, so what you're going to notice on today's assignment is the directions are going to say this: solve each system by substitution. Now, before we get into actual examples and before I show you what is exactly going to be done on today's assignment, the thing that I want to mention is this: substitution is something that we do all of the time. Okay, when you have an equation like this, 5y plus 2 equals 17, if I tell you, or if I ask you, is y equals 3 the solution? How do we check the solution y equals 3? And what everybody always says is, the expression they use is they say plug it back in. Plug in 3 back in for y and check. Well, what I want you guys to embrace is the idea that when you say plug in, what you're really saying is substitute. This equation tells us that y is 3. So what that means is that the letter y is interchangeable with the number 3, which is why you can go back in right here and you can replace the letter y with the number 3. And again, the act of plugging a number in for a variable is what substitution is. So obviously, everybody knows how to do this. We plug 3 back in for y. 5 times 3 is 15. 15 plus 2 is 17. If both sides end up equal, we say, yeah, it checks out. That is a solution. The point I'm trying to make for you guys here is this: that act of plugging something back in for a variable is the act of substitution. Okay? So here's what the examples are going to look like. And if you are, like I mentioned yesterday, if you have your notes notebook at home, and if you actually copied in the notes from yesterday into your notebook as you watch the video, feel free to just continue to add this stuff on, okay? Yesterday we did a couple examples of solving systems by graphing. Now we're going to solve systems by substitutions. And again, if you want to copy these notes into your notebook so you've got them for later when we come back together and we're not learning remotely, feel free to do so. Pause the video as you need to, okay? The first system I'm going to give you is this, okay? I'm going to give you two equations. The first one you're going to look at and you're going to notice is going to be in slope-intercept form, y equals negative 2x plus 7. And the second one is not going to be in slope-intercept form. It's going to look like this: 5x minus 3y equals 23. Okay, so again, here's a system of equations, and our job is to solve that system, meaning figure out what those x's are and figure out what those y's are. The thing is, today we're not going to graph. So even though this top equation is in slope-intercept form, it doesn't matter. Okay, we're not worried about slope-intercept form or anything like that today. All we're focused on today is the method called substitution. So what I need you all to embrace right now is this: what did we do up here to check to see if y was in fact equal to 3? Well, we went to our other equation and we plugged 3 in the place of y. That is exactly what we do down here. This top equation tells me that y is equivalent to negative 2x plus 7. So it's not y equals 3 now, it's y equals negative 2x plus 7. But what you're going to notice is we do the same thing we did up here, where we took the y out and we replaced it with the 3. Everything else stayed the same. You're going to do the exact same thing here. You're going to take that y out and you're going to replace it with now negative 2x plus 7. Okay? Everything else stays the same. The 5x minus 3 times negative 2x plus 7 equals 23. And again, by showing you that initial example, this initial concept of what substitution truly is, I'm hoping that kind of makes this make a lot more sense. Substitution is when you just take a letter out and you replace it with what it is equivalent to. So the top equation tells me that y is equivalent to negative 2x plus 7. So that's what I did. I replaced the y with negative 2x plus 7. Here's where section 1 comes into play. All you do with this, now that you've gotten rid of the y and all the variables are x's, now you solve this. So again, this is why we did section 1 this year. This is why, let's see, last Monday we did a review of solving regular multi-step equations because I knew this was coming back. We have to be able to solve for x here. So what did we talk about last Monday? We said the first step in solving is get rid of parentheses by distributing. So I need to distribute this negative 3 into those parentheses. Negative 3 times negative 2x is positive 6x. Negative 3 times 7 is negative 21. Everything else other than the distributive property drops down. So bring down the equals 23, bring down the 5x. All right. Step 2 was get rid of fractions if you have any. We don't have any fractions here. Step 3 is look at the two sides and get them down to 2 terms. This left-hand side has 3 terms, which means 2 of them are like terms. I can put those 2 terms together. 5x plus 6x is 11x. Minus 21 equals 23. And at this point, we're down to the last 2 steps of solving. All we have to do is add 21 and then divide by 11. So add 21 to both sides. We get 11x equals 44. Divide by 11. We get x equals 4. Now I'm going to put a box around that. Here's what this tells me, you guys. This tells me that in my original system, back up here, these 2 equations, this x is really a 4, and so is that x. Both of these x's in the original problem have to be the same number. So in this case, that number is 4. The thing we still have to do, you guys, is we still have to figure out what both of these y's are. The way that we do that is it's basically this. Now we know that x is 4, so go back up and take either one of these original equations. I'm going to take the top one, and I'm going to rewrite it. Y equals negative 2x plus 7. But what I'm going to do is I'm going to substitute or plug in what I know x to be. X is 4. So I'm going to replace the x with 4, and this will now allow me to solve for y. Y equals negative 2 times 4 is negative 8. Bring down the plus 7. Negative 8 plus 7 is negative 1. Okay, so there's my y value. I want to show you a couple things, okay? This is what you're doing today, okay? This right here is all bonus material. This should help you connect the dots with everything we're doing, okay? Here's what I want to just point out real quick. The fact that we get x equals 4 and y equals negative 1 means those are the 2 numbers I should be able to plug in to both of these equations and have them check out. So my top equation, y equals becomes negative 1 equals. The negative 2 times x becomes negative 2 times 4, and then plus 7. And what you guys will notice is this is going to check out. Negative 2 times 4 is negative 8. Negative 8 plus 7 is negative 1. It checks out. Negative 1 equals negative 1. Okay, so if I plug in 4 and negative 1 to my top equation, it checks out. Let's do it to the bottom equation. 5 times x becomes 5 times 4. Minus 3y becomes minus 3 times negative 1, and then equals 23. Ran out of room just a little bit there. Let me make sure you guys can still see it. 5 times 4 is 20. -3 times -1 is +3. And then if you add them together, you get 23 equals 23. It checks out. So the fact that it checks out tells me these are the correct answers for x and y in both equations. It checks out for both equations, which is what it means to be a solution to the system. Here's the other thing I want to point out. If you would have graphed these, if you would have graphed this equation right here, the top one, you'd got a line that would have looked something like this. I'm going to kind of just wing it here. +7 is a y-intercept, -2 is the slope. It would have looked something like this. Okay? Now, this one you'd have had to convert into slope-intercept form, but what ended up happening is you'd ended up getting a line that looked like this. Okay? And the point that they intersect would have been over 4 down 1. So the last thing that you guys are going to do today, you're not graphing today. You don't have to check your work today. Instead, what you're going to do is you're going to solve the system by substitution, but the way that I want you to write your answer is the same way you wrote your answer yesterday, which was as an ordered pair or a point. X is 4, y is -1. So this is the last thing that you guys should do today. You should write your answer as an ordered pair. So put your x and your y together as a single ordered pair. Okay? Now, with the next two examples, I'm going to work considerably faster, you guys. Okay? I'm going to work a lot faster with these because I don't want this to take too long, but I want you to see how all of these are interrelated ideas. Okay? Here's the next example I'm going to show you. X minus 7y equals 11, and 5x plus 4y equals -23. You got to solve by substitution. So the kicker. In this first example, I had an equation that was solved for y. It was y equals -2x plus 7. What you notice here is neither one of these equations are solved for y or solved for x. So what you're going to do today is this. If neither equation is solved for either variable, you're going to pick one of the equations. I'm going to pick the top one, and you're going to solve it. The reason I picked the top one is because x has no coefficient. So this x is really easy to get by itself. All I have to do is add 7y to both sides, and here's what I get. X equals 11 plus 7y. Here's my substitution equation. This equation tells me that x is 11 plus 7y. So this tells me that I can plug in 11 plus 7y for x in the other equation. So here's the x. That x is going to get replaced with 11 plus 7y. Everything else is just going to come down. So what was 5 times x is now 5 times 11 plus 7y. There's the substitution. Substitute x out, substitute 11 plus 7y in, everything else stays the same. So bring down the plus 4y equals -23. And from here, like I said earlier, this is where chapter or section 1 of this chapter kicks in. You're going to solve for y. So first step in solving an equation is to distribute to get rid of parentheses. 5 times 11 is 55. 5 times 7y is 35y. Bring all this stuff down. Plus 4y equals -23. I've got like terms. I can put them together here. 35y plus 4y is positive 39y. Bring down the 55. Bring down the equals -23. And at this point, we're down to our last two steps of solving an equation. Subtract 55. We get -78 equals 39y. Kind of scary looking numbers for a second until we divide. Divide by 39, you get y equals -2. -78 divided by 39 is -2. So there's our answer for y. We still need our answer for x, but the nice thing is we have a really nice spot to go plug -2 back in. It's right here. Plug it into the equation that was solved for x to start with, or that we solved for x to start with. X equals 11 plus 7 times y, but we now know y is -2, and now we can solve for x. Positive 7 times -2 is -14. So this becomes 11 minus 14, which is -3. So -3 equals x. And from here, the last thing to do is put x and y together as an ordered pair. My x coordinates -3, my y coordinates -2. If we would have graphed them, the point of intersection would have been the point -3, -2. This is just a shorthand way of writing your answer, x equals -3, y equals -2. Instead of getting two separate answers, we put those two answers together as an ordered pair. Okay? Now, we've got about 5 minutes left here. All I really want to do is show you the last scenario that you could run into that is going to be the least convenient scenario, okay? So here it is. I'm just going to give you another excuse me, another system. We're going to go 12x plus 2y equals -27, and then 3x plus 8y equals 9. Okay, same deal. You're going to notice here that everything is going to be very similar once we get done with our initial step. The initial step that you have to do is you got to look at your two equations, and one of them you have to get, oh, sorry, this shouldn't be -27, my apologies. That should be -54. -54, if you're copying along here. Anyways, at any rate, what we have to do here is this. We have to take one of our equations and we have to get either x or y by itself. So what you'll notice here is all four of your variables have coefficients, 12, 2, 3, and 8. Pick the smallest coefficient. So the smallest coefficient I have in this problem is 2. Use that one to isolate a variable. So what that tells me is I'm going to take this top equation and I'm going to isolate y because it's got the smallest coefficient. So what we do is we subtract 12x from both sides, subtract 12x there. We bring down our 2y equals -54 minus 12x. I can't put those together because one's got an x and one doesn't. And then the last step is to divide away 2. Divide everything by 2 and you get lucky on this one. -54 divides by 2. It's -27. And -12x divides by 2. It's -6x. Here it is. Here's your equation that tells you what to substitute out and what to substitute in. Take out y and in its place plug -27 minus 6x. The thing you got to keep in mind is you have to do this substitution on the other equation. So we use the top equation to get y by itself, which means we need to use the bottom equation to plug in for y. So here it is, 3x plus 8, but in the place of y, I need to make those parentheses just a fuzz bigger here. In the place of y, I'm going to replace it with -27 minus 6x, and then bring down my equals 9. This is where you'll notice there's a ton of repetition today, okay? So if you can do this once, you can, odds are you can do it as many times as I ask you to do it. I think there's 6 questions on your assignment. First step in solving this equation is always going to be distribute. 8 times -27 is -206, I believe. Let me double check my math there. 216, actually, -216. Okay, 8 times -6x is -48x. Bring all this other stuff down. Bring the 3x and the equals 9 down. This side is almost always going to have like terms. So 3x minus 48x is -45x. Bring down this -216 and equals 9. At this point, we're just hoping that our number ends up working out to be an integer. So I'm going to add 216. We get 216 plus 9 is 225. equals negative 45x. Let's see here. Perfect. Divide by negative 45, divide by negative 45. It works out to be x equals negative 5, and that's exactly what we were hoping for. We were hoping for an integer. Once you get one of your numbers, in this case you get x, go to that other equation that allowed you to do your substitution, and that's what you do your final round of substitution for. Y equals negative 27 minus 6x. But again, one more round of substitution. X is negative 5, so substitute it in, and here's what we get. Negative 27, negative 6 times negative 5 is positive 30. Negative 27 plus 30 is 3. So there's my x and my y. Last thing to do is put them together as an ordered pair. Negative 5, 3. Okay? So there's good news, there's bad news, and then there's more good news. The good news is you've done this before. You did it in Algebra 1. The bad news is it's kind of frustrating. Okay, so a lot of people historically tend to struggle a little bit with solving systems of equations. So obviously what ends up happening for certain students is they say, I'm just not good at this. I'm just going to not necessarily do well on this part. Well, here's the other bad news. The bad news is when we finally take a quiz on this, it's going to account for most of the points. You have to be able to solve systems by graphing, by substitution, and then by the third method that we're going to get into in the next couple days. So don't fall behind on this. Don't just say, I'm not good at this. You have to work hard. You have to ask questions, okay? So if you need help with these, ask me. I can set up a Google meeting with you and I can walk you through some of these. Or I can just give you more examples. I can provide another video for you guys if you need it. But ask questions if and when you have them, and make sure you're doing the homework and doing the practice on this stuff, okay? All right, guys, that'll do it for now. Shoot me your questions as you have them today, and we will go from there. Have a great day. Talk to you later.